Okay, so this is meant to prepare you for the algebraic manipulation test number 1. So, first thought is, if you have this, what do you have to do before you do anything else? Divide by 3. You got to get that absolute value alone. So everybody do that. And now you have x plus 5 is equal to 15 divided by 3 is 5. All right. Now at this point, a lot of kids want to subtract 5 from both sides. You cannot do that. Why not? Because it's in absolute values. You have to get them, set them free from their chains. They're chained up in there with the absolute values. So you break them out. And you say x plus 5 has to equal 5. And x plus 5 has to equal negative 5. Because remember, what's underneath my scribble here has to either be a 5 or a negative 5 for this to work. All right, so now, minus 5, x has to equal 0, minus 5, x has to equal negative 10. Could that be right? It is. So I got two different answers there. Now, what if my grade depended on this and it was really important, which, by the way, on the test, it will. You only have, like on the R2 section, you're going to have 8 questions. That's a small number of questions. Like small enough that you could get one wrong and it could drop you a whole grade. Okay. Now, you can get one wrong out of 8 and not have a problem. In fact, it doesn't hurt a thing. You can even get 2 wrong out of 8. But now all of a sudden you're at 6 out of 8, and that's your 3/4 of the deal. And now you've got, you know, you've done well. But if you get one more wrong, it's going to drop your whole grade. Okay, so it matters. Each question matters. So you got to be careful. So how am I going to make sure this is right? I'm going to go back and check. I'm going to stick in a 0 here. See if it really works. 3 times the absolute value of 0 plus 5 would be 3 times the absolute value of 5. And that's 5. So 3 times 5 is 15. It worked. I checked it. I know this one's right. Why do you want to do this? Because sometimes you've made a mistake. And you'll catch yourself. All right. X is negative 10. I stick in a negative 10 here. And I see if it really works. So this comes out to negative 5. Absolute value, that is 5. 5 times 3 is 15. It works. They both work. Yay. And I'm done. All right. Raise your hand if you're comfy with that kind. Okay, good. That's one of the R2 kinds. Pretty simple. There wasn't much to do on it. Just had to know how to break up absolute values. All right, what happens if the same kind of a problem wait. Let's make this 25. There we go. Okay, except now I'm going to make one little change. Wait for it. Last changes the whole problem around. Because now I'm not just going to get 2 answers. I'm going to get 2 answers. Those are numbers on a number line. Then I got to test, is it in the middle that works or the outsides that work? All right, try it. See if you can handle this one all by yourself. Remember, do it the same way. Get your 2 numbers the same way, but then put them on a number line. Pause while you get that going. Here we go. I'm going to start by adding 5 to both sides, and I get 2. Absolute value of x plus 5 is equal to, no, less than or equal to 30. And then I divide by 2, and I have x plus 5 less than or equal to 15. Are you with me so far? Good. Now I can split it. Split. X plus 5 is less than or equal to 15, and x plus 5 is less than or equal to negative 15. Do you get why I can do that? Because what's underneath here is either 15 or negative 15. See, 15 or negative 15. All right. Now, I'm going to subtract 5 from both sides. X is less than or equal to 10. 15 minus 5 is 10. And subtract 5 here. X is less than or equal to, be careful with that, negative 15, and negative 5 makes negative 20. A lot of kids make a mistake right there. Okay, the next thing is, I'm not done. I have to, oh, wait a minute. I made a little mistake, too, that's kind of important. It doesn't matter that much, but because you usually don't look at these signs very much, but that sign is wrong right there. Because when you change that to a negative 15 over here, that's like multiplying by a negative. You remember what you do to the sign then? Flip it. So that should be greater than or equal to. Again, teachers don't even teach anything about these signs. So you don't really have to have them there, because all it matters is our 2 key points. But when I do this, I like to use those as like an extra way to check my answer. Because I hope you know that this means there's two answers, negative 20 and 10, that are kind of important. But then the question really is, which numbers work? The numbers between them, or the numbers down here, or the numbers up here? The green zone, the black zone, or the red zone? All right? And these signs here can help me. Look at this. It says less than. X is less than 10. Do you get that that rules this area out right there? I don't even have to test anything in that area. It'd probably be smart to, just to be safe, but... And then this one. If you switch the sign correctly, you notice I switched it, greater than negative 20. That means that that rules out this area there. You get how I know my answer is in between? Now, if I wanted to be sure, I might test the number in between. So let's test something between 10 and negative 20, and 0, my favorite number to test, is in between there. So I'm going to test a 0. I put in a 0. Oh, I put it in the wrong spot. 0. And that's going to be absolute value of 5 is 5. 2 times 5 is 10. 10 minus 5 is 5. Is 5 less than 25? Yeah. Worked. So it's this area right in there. If you leave it like that, I have to mark it wrong. Because the directions will say write the answer in interval notation. So negative 20 to 10. And then there's another part. Do I use brackets or parentheses? Because it says or equal to on the signs, I use brackets. That means the endpoints work. But well, let's say you forget that, and you forget if it's the or equal to's or the not or equal to's that you want. Then test a point. I'm going to test the 10. See, that's one of my endpoints. I'm just going to see if 10 works or not. I put in the 10. 10 plus 5 is 15. 2 times 15 is 30. 30 minus 5 is 25. 25 is less than or equal to 25. Notice it's the or equal to that makes it work. Okay? Raise your hand if you're comfy with that kind. Good. So then, you're probably at the point where if you can do one more right, you'll be able to get a C on this test without doing any of the R3s. Okay, because R3s, so far you haven't done any R3s yet. Those are all R2s. Try this one. So then you got root x plus 3 is equal to 15 divided by 2. I'm just going to leave it as 15 over 2. Could you make it 7.5? Sure, you could. Sorry, 15 over 2. All right, next. How do I get rid of the squared root thing? Square it. I square this, I square that. And I have x plus 3 is equal to 15. Now this kind you can just square each item. 15 squared and 2 squared. And that makes 225 over 4. And then just subtract 3 from both sides and I'm done. But let me show you another kind that would be harder. And that would be like this. 2 times square root of negative 11 minus 5x is equal to 2x minus 6. This is hard enough that it'd be more like an R3 size. Okay, this would be the kind you need to get right to get an A or a B. Give this one a shot. That same piece of paper you started the hour with? Okay, I think you know what the problem is. Some people are on the third piece of paper. You're in the top 1 inch of your first piece of paper. So either you write incredibly small, or you're not doing the problems with me. So do the problems with me, please. Not buying it. I know you're generally staying with me. I can tell by your eye contact and stuff, but just having to have to trust me on this one. I'm strict about it. You don't want me on your back every class. Do the problems with me. Nope. You have to trust me. You need to write it out. It makes a difference. You'll do better. Wouldn't it be easier for me to just ignore you? Then I know that's what you'd rather have me do. But to be a good teacher, I have to do the best thing for you, which is writing it out, engages the different part of your brain, helps you to remember it better, works better in the long run. But that doesn't work as well. There's too many steps to just do them all in your head, okay? And you know, if you have some sort of a writing disability, that would make sense to me. You know, like really, like some kids, they have what's called dysgraphia. They can't write things out well. They can just think and they can't really write. Okay, but I don't think you have that. I think you have. I really don't want to write a, which is not an actual disability. All right. So on this one, I'm going to get rid of the 2 by dividing by 2 on both sides. Divide by 2, divide by 2. And then this part cancels, and then I have this. And then I have, oh, a bunch of numbers cancel there. Okay, so see how there's a 2 in everything? There's 2 in this, 2 in this, 2 in this. Okay, 2 goes in here once, 2 goes in there 3 times, 2 goes in there once. So it's x minus 3 over 1, which is x minus 3. Now when I square both sides, this square root will just come off. This is not the kind where I square root both sides and have to have an absolute value. That's a different kind. Squaring both sides doesn't cause that. But here's where a lot of kids are just going to say x squared minus 9. Be honest, how many of you made that little mistake? Nobody in here made the mistake? Okay, maybe you just haven't got that far yet. All right, x minus 3 times x minus 3. That's what you do when you square something, and it will be first, outside, inside, last. Go ahead and do that part. And then you'll have a quadratic. And I'll tell you, this one will factor if you do it right. Once you set it equal to 0, it'll factor. If you can't factor, this test is not going to be very fun for you. Factoring is going to come up several times. All right, so I'm going to go negative 11 minus 5x is equal to x squared. Outside and inside makes minus 6x. Last make plus 9. Now I'm going to get the stuff over to the other side, and I'll have 0 is equal to x squared, and then the negative 5 makes, add 5 to both sides, and that makes that negative 6 into a negative 1x. And then the adding 11 to both sides, 9 plus 11 makes 20. All right. I think I made a mistake in setting up the problem. All right, I think I know what I did. I think I wanted that. Tell me what I could have done with 11. That would have been smarter. If it had been a regular 11 instead of a negative 11, when I made the problem, if this hadn't been negative, it had been plain 11, then if I subtract 11 from both sides, this would be negative 2 at the end here. Yep, that's what I wanted. Sorry about that. Erase back and change. Just get rid of the negative on this thing. So in case you're looking back at your notes later, the negative isn't there. I'm sorry. You're the first class I tried this one on. And they're really complicated to set up right. All right, so now that's a regular 11. I'm going to subtract 11 from both sides. It'll be minus 2. Now I think it factors. Doesn't it? Yes, yes, it will. And now this next part, to get this negative 2, I have to do something times something makes negative 2. Negative 2 times positive 1 would make negative 2. And then would my outside and my inside make negative x?
Yep.
So it worked. So I got 0 equals, well, no, I don't need to do that again. I already got that. Now I can just say, what are the answers? X equals 2 and x equals negative 1. Yay. Imagine if this whole thing had been a greater than sign at the beginning. Now you'd have a number line to do. Okay? But it's not. It was an equal to at the beginning. All right. See how that's... Each individual part isn't that hard, but you got to know how to factor. You got to know how to set an equation equal to 0. You got to know how to multiply things out that are squared and not screw it up. You got to know how to get rid of a square root. And you got to know how to do this kind of canceling. Remember how at the beginning of the year we said you had to know all those things? That's why we tested you on all those things, because now they're coming back. And in one problem, you have to do 6 different things. And if you have to know those 6 little kind of things, each little piece isn't that hard, but you put all 6 together, it's easy to mess up. All right, let's try another one. I'm focusing on the parts that don't require a calculator. All right, so next kind is I'm going to give you a problem that's got a whole bunch of words, and you have to translate that into an equation. Okay, and here it is. 2 times the cube of the number. You have to be able to translate that into an equation. Don't write the words. Just write the variable like 2x cubed or 2n cubed. Or x is fine. And then increased by 4 times its square. Increased by. Keep going like that. See if you get the right equation. I want to see how many of you get the whole equation right. So that's half the problem, is just translating it from words into an equation. Question? Which one? Part. Yes. I know my handwriting's pretty bad. All right. 2 times the cube of the number increased by 4 times its square less 3 times the number is 6. And the is 6 means equals 6 at the end. Less means minus. And 3 times the number means 3n. All right, so here it is. 2 times the cube of the number. You get that that's this. Does that make sense? Okay. Next. Increased by 4 times. 4 times. Its square. That's its square. Then less 3 times the number is 6. There we go. There it is. Raise your hand if you had that one right. Awesome. Then you got a shot at this one tomorrow. But you're only started because now you have to be able to factor this whole thing out, and it's that special kind of factoring. So to start with, I'm going to pause the video, get the door shut. Okay, I'm back. So I need you to put that 6 on the other side, set it equal to 0. Remember, without a calculator, we pretty much always have to set them equal to 0. If we had a calculator, we just graph both sides, see where they crossed. But since you don't have a calculator for this part of the test, set it equal to 0. I'm just going to rewrite it one more time. 2n cubed plus 4n squared minus 3n minus 6 equals 0. Now we need that special kind of factoring because it's got 4 parts to it. You can't just slap up 2 parentheses and factor it. Do you remember this kind? This is kind it's called divide and conquer. Divide it down here, factor out this part. Once you're done with that, factor out that part. Try it. Just see what factors out of this first part. I know you probably noticed that there was an n in common. Did you notice there's also a 2 in common? So actually 2n squared is what comes out. N plus 2. Raise your hand if you did that part right. Good. Now how about over here? What's in common? 3. In fact, I could factor out a negative 3, couldn't I? Take out a negative 3, and I'd have n plus 2. Now, if you had taken out a regular 3, you'd wonder like what to do with the negative, and it'd be really confusing. So it's best to just factor out the negative 3. Again, if I multiply this back in, it'll get me what I wanted. And notice these are in common. That's the key to this whole thing. Since those are in common, they can come out to the front. All right, so if those n plus 2's can come out to the front, now if I'm dividing here by n plus 2 and dividing this by n plus 2, then what do I have left when they drop off? This and that. Again, if you want to check, multiply this times this, and that times that, and you should get this and that. All right, do you get how it's factored? One more little gotcha in here. A lot of times we have problems where you factor it down and you got this. You've done all this work to factor it, and you get down to here and you think you're done, and then it's not factored all the way because there's one more thing. Do you remember this kind? Remember that can factor? I'm making up a new problem now. This is not what we had before. If I had this problem, though, I'd have to factor that last to n plus 1 and n minus 1. Remember that? Okay, don't forget that. So this is not factored all the way yet. Now I'd have my answers. Negative 2 would be here, negative 1, and positive 1. Okay, for that problem. That was just a little aside because I know it's important. Okay, next. If I go back to this thing, I now know that this has to equal 0, and that's easy if n equals negative 2. And this equals 0, I better write that one out. Set them both equal to 0, and then you solve them. N squared equals 3 over 2. I'm really close. How do I get rid of that squared at the end there? Square root both sides. And n equals square root of 3 over 2. And you could go that far and then get it wrong. Can you imagine? Why? Plus and minus, because the square root on both sides is where you got to do the absolute value. You're going to forget it. Unless I annoy you enough with these ahead of time and keep you from forgetting it. When you do the square root of n squared, it's the absolute value. That means there's two answers. N is equal to root 3 over 2, and n is equal to negative root 3 over 2. Now, let me throw one more thing at you. That's an answer, and that's an answer. Notice that there's 3 answers. When should you know to look for 3 answers versus 2? The problem is a cubed in it. It's going to have 3 answers. All right. Okay, so the first part of this, everybody pretty much had this. So we were good on that. The next part was we had to set it equal to 0. That's not that hard. And the next part was the factoring part, which got a little weird because we had to do this divide and conquer thing. Factor the first part, factor the second part, and then take this that was in common and put it out to the front here. and then whatever was left went in here. Then each part of this had to equal 0. N plus 2 had to equal 0, and that works if n is negative 2. And this part here equaled 0. And then I solved that, and then whoopsie, right there. Kids are going to forget that. You have 2 answers there. The way you could have known is if you got 1 answer here and 1 answer here, you only have 2 answers. And you're just like, wait a minute, I'm supposed to have 3 answers. See, because of this. All right. Do you feel your brain getting bigger? Learning anything? I hope so. All right. Next part. This one. Tell me what you think. Wait a minute, how come you're stopping already? Yes. There is no solution to this. You're right. Done. You get how a lot of kids would just solve it and they get answers? And they'd be wrong? Because an absolute value can't be a negative. So there is no solution. Now watch. Let me show you how I would have caught it if I did it wrong. Okay, I go, okay, I think I split it. X minus 7 equals negative 10. Yeah. And x minus 7 is equal to negative of negative 10. That would have probably made me notice it right there, but negative 10 would be positive 10. And then I add 7 to both sides and add 7 over here. If I actually took the time to go check those two, they don't work. Watch, if I put in negative 3 here, that comes out to negative 10. What's the absolute value of negative 10? 10. It's not negative 10. See, it doesn't work. Doesn't work. Doesn't work. And I want to warn you, sometimes only one of your answers works and the other one doesn't. So you ought to check every single answer you get. Because sometimes you're going to have done the problem perfectly and have 2 answers and then one just doesn't work. You know, that's weird. It's called an extraneous solution. It just happens. It happens more often when you have square roots or absolute values like this. Yes? If you notice at the very beginning, you can just be done and say no solutions, and you'd have to say, you know, maybe put an arrow to this or something and then say no solutions. Just an answer of no solutions without any work will not be given credit. You just say why. Say something like absolute value can't be negative. All right, so another one for you to try. Try that one. So what's the answer? All right, good. No solution. Just going to see if anybody got sucked in. There's a lot of people writing, so. All right. How about if I change this to a R and this to a P? And I said, in interval notation, write what values are allowed for R and for P. Let's just talk about R first. In interval notation, that means one of these little dealy-bobs. Could be a brackets, could be parentheses, whatever. Okay? What do you think R can be? Have I said anything about how that can't be negative? So that could be positive or negative. So what could it be? Negative infinity to positive infinity. And it'd be parentheses around both, because you can never get to infinity. How about that guy? What can he be? Can't be negative infinity. 0 to infinity, and can it be 0? An absolute value can be 0. You get that? It's a more algebraic way of thinking of it. Like, these are things that are allowed and these are things that are not. All right. So how about this? How about that one? How should I start? Come on now. Look at it. Can anything squared equal negative? Once again, no solutions. Could you have done it the long way, gotten answers, checked them, and realized, crap, nothing's working? And hopefully at that moment you would have said, oh, nothing squared can ever come out to be negative. Yes, ma'am. You may write no solutions as long as they have said we want the real solutions. If they ask for imaginary solutions, then you have to do it with an I. So like if it comes out to, say you've done the work and it comes out to 2 plus or minus square root of negative 4 all over 2. If the question was asking, can you have any real answers, what would you say? No, there's no real answers because there's a negative under the root. What if they say, I want all the solutions? Can you do this part right here and as an I? What would that be? 2I. And then you'd have 2 plus or minus 2I over 2. And then the 2's can cancel, turn into 1's. And then you'd have 1 plus or minus I over 1, which is just that. So if they want real solutions, that's not real. That's imaginary. But if they want real solutions, there are none. If they want imaginary solutions, then this would be it. But the ones where they say only real, or we only want real numbers are nicer because then you can just say, there aren't any. All right, moving on. How about if you had 3x cubed plus x squared is less than 2x. If this was a graphing test, I would graph both sides and see where they cross. It's not. There's no calcs. So what are you going to do? Set it to 0. A lot of people get confused because there's so many x's all over the place. So what do you do to fix that? Take an x out of everything. And what would I have left if I took an x out of everything? 3x squared plus x minus 2. And I betcha that you can factor that. Do it. Remember, this is a less than problem, which means your answer is a number line. And then interval notation at the very, very end. For many of you, this is the hardest math class you're ever going to take. And I will work really hard to help you understand it, but you have to also then do your part, which is for tonight. There's a worksheet that I believe he gave you yesterday. Didn't he give you the review worksheet ahead of time? Okay, and if anybody didn't get one, they're right here. If you didn't get one yesterday, raise your hand. I'll hand you one right now. All right. And not only would I do this worksheet, there's a tendency for kids to go and do the easy ones, and the last two, like 9 and 10 on this worksheet, are word problems, and go, oh, well, those are just word problems. Those are really hard. You know what? If you can only do the regular problems, you're going to get a C on this test. Because all of these top ones, those are all like R2s. The R3s are like the word ones. You have to understand, and why would we do these word problems? Maybe because it's a review for the test. Maybe those are important word problems. Okay? Know how to do them. If you don't know how to do them, and you look at the key, try to understand what they're doing, because, you know, just writing on the answer is pretty pointless. All right, so that's how you study tonight. And then if you want extra help, I'm here in the morning, and I'll be glad to work with you. But there'll probably be 15 kids here, because I have 3 classes, 90 kids. And I have people from other classes, other teachers' kids come and get help here too sometimes. So I end up with lots of kids. So I'll help you as much as I can, but there might be 15 kids here, and each of them wants 3 problems. I can't do that many problems in an hour. Okay, so I might be able to help you with 2 or 3 questions as long as they overlap with what the other kids want to know about. So what am I trying to say? Don't come in and help for help? No. It's do your homework first. Check it first. Then come in after you've already studied. The worst is some kids think, well, I'll just go in the morning to study. It won't work. You got to do the stuff ahead of time. And then come in and ask me about the couple that stumped you. Okay, that'll work. All right, so here we go. I was giving you some time there to factor this puppy, and hopefully you said 3x and x, and then how do I make it 2? Well, that's not too hard. 1 times 2. One of them's got to be negative. So I'm going to try it this way, and try it this way. And then the outside and the inside. Yay! I guessed right. If I hadn't, I would just rearrange them until I found it. But this one works because the outside makes 3x, the inside makes negative 2x. The total there is x. Okay. And so now I'm going to solve this thing. I know this has to equal 0. X equals 0. That's the answer. I know this has to equal 0. 3x minus 2 has to equal 0. Solve it. 3x equals 2. X equals 2/3. And the last one. X plus 1 has to equal 0, so x has to equal negative 1. Answer. 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 There's 3 answers. Does that make sense? It took this to the third? Yes. But here's the problem. I'm not done. Because it's a less than sign. So now I have to do a number line. All right. Backing up a bit. Yes. Did I goof it up? If I go this times this, that's 3x. Do you agree with that? 3 times x is 3x. And then, wait. And then, what's negative 2 times x? Negative 2x and positive 3x makes a total of positive x. It does work. Okay, thanks for stopping me, though, because if I was making a mistake, I would have been screwing up 30 people. So, or 32, actually. I just made the count. All right, so I've got 3 answers. What do I do with them? Now I got to put them on a number line because this is one of those things. It's a less than. So I got to have a number line now with a negative 1 and a 2/3 and a 0. I guess that would be in between here. And now I got to figure out where does it work? In the black zone? In the green zone? In the blue zone? Or in the red zone? Red zone is for unloading and loading only. All right. So now I got to test a little spot in each one of these things. Pain in the butt. All right, so I'm going to try like a bigger number, like 2. Something over here. See if that part works. So I stick in a 2, and I see if it works. And then it'd be even nicer to do a 1, wouldn't it? And 1's still in that zone, so I'm going to do a 1. So I'm going to test a 1. So then I go 1 cubed is 1, times 2 is 3, 3 plus 1 is 4. Is 4 less than 2 times 1? Is it? No, that didn't work. 4 is not less than 2. So that part doesn't work. And you just keep testing little parts. Now I got to find something between 0 and 2/3. That's a pain. Like 1/3. I could do that. So I go stick in a 1/3 right here. On a 1/3 right here. What a pain. Yeah. It wouldn't be that bad on the test, but you'd have to test each little interval, including if it's a decimal. I think there might be one like that, where you have to test something like between 0 and 1 and negative 1. So that's like the only thing between 0 and negative 1 that's nice would be negative 1/2. So if I'm testing negative 1/2, I put it in right here and cube it. Put it in right there and square it. Put it in right there. And make negative 1 over there. All right, so you test each part and you see where it works. And it'll probably only work in one area, but sometimes it works in 2. The only other easy one to test is this one down here because they're not decimals, so like negative 2. So I could test a negative 2 in here. I'll do it in black so you can read it easier. 3 times negative 2 cubed plus negative 2 squared less than 2 times negative 2. And this would be negative 8 times 3 is negative 24. Negative 24 plus, that's a positive 4, will be negative 20. It is negative 20 less than negative 4. Now you have to ask yourself, what does that mean if a negative is less than another negative? What they're asking really is like on a number line, which one is warmer, is bigger? So this one is colder and therefore it's smaller, and so that's right. It's a true statement. Negative 20 is less than negative 4. It's colder and therefore less than. So that worked down here. So that's an area that worked. Now I could test, and it would take me a long time to figure out if both of these worked or if only one of them worked. My guess is that this one works and this one does not work. It's my guess, but anyway. Then you'd write it as an interval when you're done. All right, so that's like the hard kind. One more on the hard kind side. Averaging. Do you get, if I have a score of 80 on this test, 85 on the next test, 90, I'm going up, yay, I got one more test to take, but I want to average a 90. Do you get how I take this, plus I don't know what, and if I wanted to average a 90, how do I write that? What do I have to do on all these to average them? Divide them by what? 4. And if I want all of that to average a 90, I'd say I want all of that to be greater than or equal to a 90. See what I just did there? Added them all up, added the mystery number, divided them by 4, and I want that greater than or equal to 90. Does that look like an equation then? And I could just start by multiplying by 4 on both sides, multiply this by 4 and this by 4, and that'll cancel this 4, and this becomes 90 times 4 is 360. And then you subtract off these numbers, and then you can figure out that, gee, I need to get 105% or something to average a 90. All right. So I want to give you one like that to try. Same idea, except let's say that it's there's 5 games left in your season. And your coach puts out an incentive and says, anybody that can average, let's say this is basketball, anybody that can average 10 points a game, I am going to throw you a big party and, bring you to our last day in a limo or whatever. Okay, so you want to average 10 points a game. Let's say that you get 5 points, and you get an awesome one, 12 points, and then you get 9 points, and you have one more game, and you want to average 10 points a game. What? Okay, I'll have thrown one more score then. Let's say we have an 8, and then the mystery game. So in the 5 games, the last game we don't know, write the equation for me. So you'd say 5 plus 12 plus 9 plus 8 plus n all over what? 5 has got to be what? Not just equal to 10. Because your coach is not going to say, oh, you got 11 points a game. You don't qualify. Right? He's going to say 10 or better. Right? So greater than or equal to 10. All right, so then I'm going to multiply by 5 on both sides, and I'd have 5 plus 12 plus 9 plus 8 plus n, and it's greater than or equal to 50, and then I'd subtract off all of these, and then I got my number. I have to have greater than or equal to a certain number of points. To be honest, I don't know what it is, but anybody know what it is? 16? Okay. So you need 16 points in your last big game. I remember a basketball game when I was a kid. I was in the high school team. And the kid, there was one kid on our team who was, our coach was big into saying, we all have roles in our team. Some of us are there to be shooting because, they're our best shooters. And others of you there are just there to pass the ball to the guy who's good at shooting. Okay, you have roles to play. And one of the guys was one of those guys who wasn't really supposed to be shooting, but he just happened to have a really good day, and he had made like 4 shots in a row. And at halftime, the coach told him, I'm happy that you're shooting well, but, we're all role players here, and I want you to, play your role and keep on passing the ball. He decided not to take the coach's advice, and he hit like 6 more in a row after that. He was just on fire that night. So I could have averaged that 16 points. Have you guys seen that one video of the autistic kid that used to sit on the sidelines? Yeah. How many of you have seen the video I'm talking about for basketball? Okay, I don't need to show it then, but that was amazing. He was the water boy, basically, and they put him in in the last game, and he just was on fire. He hit like 5 3-pointers in the real game. Crowd just went nuts. You should watch it on YouTube sometime. All right, study tonight. Check your answers at home. Come in the morning if you need help, and hopefully you'll kick some butt tomorrow on the test.